2.5b, implicit differentiation. So example 1, find the lines that are tangent and normal to the curve. Well, you can see the equation. At y, or pi over 4 and pi over 2. Okay, so in continuation from the previous lesson, we're deriving implicitly, which means there's x's and y's in the equation. And here we're just going to have to find the equations of the lines that are tangent and normal to the curve. Reminder, normal means perpendicular. Tangent, the slope is going to be the same as the slope of the actual curve. For the normal, which is perpendicular, the slope is going to be the opposite reciprocal. So first things first, we need a slope. We have a point, and that's really all we need to write an equation. Now when we find our slope, that's the slope we're going to use for the tangent, but then for the normal, we're going to use the opposite reciprocal of that slope. Okay, so deriving implicitly. So the first part here is u times v, because it's the product rule. So u times v prime. Okay, so that's a mini chain rule, right? Because of that 2. So deriving the outside, we get cosine of 2y. And then derive the inside, which is the 2y. Deriving that, you get 2 dy dx. So this is how you would write it. Alright, just do the dy dx at the end, and then the 2 is a coefficient, just goes in the front there. Okay, so u times v prime plus v, which is just sine 2y, times u prime, which is 1, so don't really have to do anything, equals. Okay, so then this is another product rule. So u times v prime, so negative sine of 2x times 2. So u times v prime plus v times u prime. So the derivative of y is 1 dy dx. Okay, so reminder, you're isolating any number that has dy dx with it. So then that means we're going to be moving this, well, I guess, you know what, let me get a pen. We'll be moving this to the left. So 2x cosine 2y dy dx minus, so the cosine 2x dy dx, this stuff here, I'm minusing that. So minus cosine 2x dy dx. Okay, so now that I've moved that over, I'm just going to go ahead and just, you know, what am I going to do with this? I'm also moving that over. But it is going to the right. So the 2 yellow parts of my equation are already on the left, so great. So now negative 2 sine 2x minus sine 2y. Oh, look what I did. I highlighted so much that I didn't even notice I highlighted part of the... There we go. That would make a difference, wouldn't it? So let me fix that. Negative 2y. I highlighted it so I didn't see it. Okay. My objective is still to get these on their own. So I would factor out. So dy dx, and then 2x cosine 2y minus cosine 2x equals negative 2y sine 2x minus sine 2y. Okay, still working on getting that by itself. So divide the 2x cosine 2y minus cosine 2x. So I'm going to divide this from both sides to get rid of it. So dy, oops, blue, dy dx, totally by itself now, equals negative 2y sine 2x minus sine 2y over 2x cosine 2y minus cosine 2x. And so here is my derivative. Now, since I need my actual slope, I need to plug in my point. No, or later. Okay, here we go. So I need to plug in this point to get my slope. So, okay, so the slope, dy dx. Oh, oops. X was pi over 4 and y was pi over 2. Okay, so negative 2 times pi over 2 sine, or times sine, times 2 pi over 4 minus sine times 2, x was pi over 4. Oh wait, did I mix my pi over 4 and my pi over 2? X is pi over 4. So this is pi over 2, this is pi over 4. So 2, okay, so it should be pi over 2. I hope. Let's see, y, x and y. Yeah. Alright, divide by 2 times pi over 4. Oops. Times cosine 2 times pi over 4 minus cosine 2. Oh. Nope, nope. This is pi over 2. This is not cooperating. Okay, y is pi over 2. X is pi over 4. X is pi over 4. Okay. So, simplify. Too far, too far, too far. Alright, so I have negative pi times sine of pi over 2 minus sine of pi over pi over 2 times cosine of pi minus cosine of pi over 2. Okay, so here is pi over 2, and here is pi. The coordinates here are 0, oops, 0, 1, and the coordinates over here are negative 1, 0. Okay. Just in case, cosine is the x, y is the sine. So, oops, negative pi times sine of pi over 2. So pi over 2, the sine is 1, minus a sine of pi. So sine pi is 0. Okay, pi over 2 times cosine of pi. Cosine of pi is negative 1, minus cosine of pi over 2. Cosine of pi over 2 is 0. So I get negative pi over negative pi over 2, which is, well, positive, first of all. And it's pi times 2 over pi, which equals 2. So there's my slope. So equations, very quickly. y minus y1, which is pi over 2, equals the slope times x minus x1, which is pi over 4. There's the tangent line. I swear that says line. And then the normal, which is perpendicular, another word for perpendicular. So y minus pi over 2 equals x minus pi over 4. Alright, my slope. So the opposite reciprocal. So negative 1/2. And there are your both equations. Alright, example 2. Use implicit differentiation to find dy dx and d2y dx2 for y squared plus 2y equals 2x plus 1. Okay, so derive implicitly. So 2y dy dx plus 2 dy dx equals 2. Okay, so every time I derived with respect to x, but there was only a y, I had my dy dx. So here I had to derive with y, so dy dx. Okay. So let's isolate stuff. Well, first of all, I could just divide all these by 2's, right? So I have y. Let's take out the dy dx at the same time. Plus 1 equals 1. So dy dx equals 1 over y plus 1. Okay, so now what's different is I was asked to find the second derivative. And to find the second derivative, when you do this implicitly, right, there's like an extra step. This is my derivative. Of course, to find the second derivative, I have to derive again. But when I derive, I'm going to get new dy dx's. So that's the extra step that goes along with implicit differentiation. I'll keep talking about it when I get to it. So, to find the derivative, I have to derive the first derivative. Or to find the second derivative, I have to find the first derivative. Use. So, this is u times v. Or, sorry, u divided by v. So I'm just going to do, what do you call it? Quotient rule. Now, I could also just do a chain rule. I could make it 1, well, not 1. I could make this y plus 1 to the negative 1 power. And make a chain rule out of it. But I'm not going to do that because for the most part, these kinds of equations you're going to have to do quotient rule. And so I just want to show you what happens when you get the extra dy dx. Alright, so again, this is u divided by v. So quotient rule is v, so y plus 1 times u prime, which is just going to be the derivative of 1, which is 0, plus u, which is 1, times v prime, which is going to be 1, but since that's y, dy dx. So 1 times dy dx. I'm just going to forget about the 1. So see, here's my new dy dx, right? There's like a new one in here, so I have to do something with that. And I will later. Okay, divided by, and then that's v squared. Alright, so y plus 1 times 0. Ooh, so that's just basically 0. So I have y plus 1 times 0. Oh yeah, 0. Minus, oh, that's supposed to be minus. Minus dy dx. That's negative dy dx over y plus 1 squared. Now, here's the thing. When you're doing the second derivative with implicit differentiation, you're going to end up with new dy dx's. So you don't try to isolate them, because on the left side of the equation, ideally, you're writing down that this equation equals the second derivative. So what you do is, you actually take your answer from before, and you plug it in for dy dx. You know what dy dx is. That's what you found initially. So just replace dy dx with what it equals. So equals negative 1 over y plus 1 divided by y plus 1 squared. And then this is a fraction within a fraction, which means you're going to use the rules to divide by fractions, which is the keep change flip. You know, you keep the first number the same, and then you change from division to multiplication, and then you take the second number and you write the reciprocal of it. So 1 over y plus 1 squared. And we end up with negative 1 over y plus 1 cubed. And there's my answer. That's the second derivative. So we found the first derivative, and we found the second derivative. Example 3. Same idea. I have changed my mind about this and x equals 1. So let's just forget that exists. Okay. So we're just going to derive this equation. First derivative is going to help us find the second derivative. Okay. So 2x cubed is 6x squared minus 3y squared is 6y dy dx. And then the derivative of 8 is 0. So isolate the dy dx. So negative 6y dy dx equals negative 6x squared. Divide both sides by negative 6y. I get dy dx equals negative 6x squared divided by negative 6y. And I hope you see that the negative 6's do in fact cancel out. So here's my derivative. Now, I need to take this and derive it again. So d2y dx2. Okay, so I have u times v, or divided by v. So v times u prime plus u times v prime divided by v squared. Okay, plug in dy dx. So 2xy plus x squared times x squared over y divided by y squared. Okay, simplify some. For example, 2xy plus x squared times x squared is x to the fourth. Obviously, this denominator, in order to actually be able to add these, this other part is going to need the same denominator. So how do you do that? Oh yeah, you multiply by that number, whatever the denominator is that you need, top and bottom. So let's see, let me get this color. So, I need to divide, so I'm going to multiply. That's what I want to do. I want a red pen. Oh, let's do purple. I'm going to multiply this by y over y, right? Because this is the denominator I need. So y over y. So then I have 2 times x times y squared plus x squared times x squared, and then the bottom is a y. Okay, and then this is a fraction that's being divided by y squared. So again, a fraction within a fraction. So all you have to do is, let's see, I'm gonna cheat here. Keep this the same. Instead of division, we're changing to multiplication. And instead of y squared, we want 1 over y squared. So you're going to do that. I get rid of this, right? Because that shouldn't be there. So I'm just going to cheat and erase it. Okay, so 2xy squared plus x fourth over y cubed. And that's it. There's your answer. Alright, last but not least, find d2y over dx2 if x squared plus 4y squared equals 1. Okay, so x squared is 2x. 4y squared is 8y dy dx, and derivative of 1 is 0. Okay, easy enough to isolate the dy dx. Gotta move the 2x to the other side, and then divide by 8y. And then simplify if you like, although you don't have to, but it would probably be a good idea. Negative x over 4y. Okay, so I have my first derivative. Now my second derivative. So d2y over dx2. So this again is a quotient rule. So v times u prime, so that's negative 1, plus u, which is negative x, times v prime, which is 4, but then dy dx. Alright, let's clean this up a little. Negative 4y minus 4x dy dx. Oh, I did it again. Why do I keep doing this? Huh, interesting. This plus is supposed to be a negative, but I keep making it pluses. Don't know why. Negative 1 minus negative x. That makes this plus. And then I also noticed that I totally forgot my denominator. Oopsie. It's low d high minus high d low over low times low, and I forgot the low times low. So that's 4y quantity squared. Okay, so back at work here. So negative 4y minus a negative x times 4, so that's positive. And then this is very much like this. Okay. The dy dx has to be plugged in at this point, right? Because, I mean, here it is. I gotta plug it in. Okay, so, let's see. Back to marker. So negative 4y plus 4x times negative x over 4y divided by 4y squared. Right, so they're going to need the same denominator. This is my denominator, so this is going to need the same denominator, which means I'm going to have to multiply negative 4y by 4y over 4y. Okay, so that gets me negative 16y squared plus, well, it's not really plus because that negative x and this negative and this x is going to become negative 4x squared. So let's just leave that. And then these are both over 4y. And then because of this right here, I'm going to have to multiply by the reciprocal of 4y quantity squared. So that is 1 over 4y quantity squared, or basically 16y squared. Okay, I'm going to keep going here. So, we have negative 16y squared minus 4x squared over the 16 and the 4 are, what, 64y squared? So now it's easy for me to see, hopefully, right, for you too, that all these numbers have a common factor of 4. So I'm going to just divide everything by 4. So negative 16 becomes negative 4y squared. The 4 divided by 4 is negative, or minus x squared. And then 64 divided by 4, which is 16, right? I'm having a brain fart. So for the most part, I could say I'm done. But this example was added on here for a reason. There are sometimes special cases where your end product, right, so like your solution, can be simplified further by using the equation from the beginning. So let me drag that down for a second. Hold on. Okay, so I dragged down the equation. So the equation was originally x squared plus 4y squared equals 1. Well, if you look at our answer, all I have to do is move a couple of things around real quick. So let me do that. So let's say I put the negative x squared in the front, and then the minus 4y squared in the back, and then the 16y squared can stay in the bottom, right? This part here is very similar to this. Very. Except for the negatives, which is okay, because that's very easily taken care of. Well, let me factor out a negative. I'm going to do it in green now. So if I factor out a negative, I have positive x squared, positive 4y squared over 16y squared. Okay, so now this is exactly the same as this. It matches perfectly. Now, the original equation told us that x squared plus 4y squared equals 1. Well, then that means that this x squared over here plus 4y squared will also equal 1. So negative 1 over 16y squared. And this is all just to make your answer as simplified as possible. That's it. So answer the practice problems, please.